So we'll start session 8. I welcome Dr. Nipun Batra sir as the speaker of the session. Today's topic will be use of Numpy, Pandas for dataset loading and cleaning datasets. Dr. Nipun Batra, our expert, is working as an assistant professor in the computer science engineering department at IIT Gandhinagar. He began his professional career as software associate RBS India. After graduating from Delhi College of Engineering, he completed his Ph.D. from IIT Delhi in 2017, where he had acquired a TCS Ph.D. fellowship also. He has even worked as a postdoctoral researcher at University of Virginia, USA, from year 2017 to 2018. Dr. Batra's work has been awarded several times. Some of his acquired accolade highlights are the best PhD presentation at ACM Census, best demo at ACM Build Sys, and a best video nominee at ACM KDD. His focal research areas of interest had been energy breakdown analysis and energy efficient smart system design. At present, his group broadly works on machine learning, AI, sensors, IoT for computational sustainability problems like smart buildings and air quality. I request Dr. Batra to please take over the session and please bless us with his knowledge. Batra sir, please carry.
Sure. Thank you so much for the very
you,
kind introduction, Dr. Partha. So I'll firstly request all the audience to participate in this session. So the better the participation, the better the learning is going to be. And I can also accordingly change. If you have questions, speak up. So sometimes it's difficult to monitor the chat. Directly just speak up if there are questions. And let's see. So I'm happy to modify this session, do it live code as per the requirements. So today's session is about Numpy and Pandas. So first, let me ask in the audience, what do you think Numpy stands for? Anyone?
Numerical Python. Numerical Python.
Numerical Python, right? So a bit of history. There was MATLAB. MATLAB has been existing for many years now, but it's proprietary. It is non-trivial, it's not cheap, right? To get a personal MATLAB license. In the Python world, there were a few projects which were coming up, which were trying to create something similar to MATLAB. But MATLAB is a lot of things. It's a very powerful set of tools. So there were some different attempts being made. One of them was numeric, one of them was numarray. But they just combined these efforts and they then created something known as NumPy, which we now use. But you'll see that a lot of syntax is in fact very similar to and very inspired from MATLAB. But NumPy by itself did not suffice all the needs. For example, MATLAB had a good plotting interface also. So that's where something known as matplotlib was also brought in, was also developed. So then you had NumPy, you had matplotlib. But then you also saw that MATLAB had a lot of optimization routines where you're doing some function minimization, some function maximization, and some lot of advanced scientific computing, which NumPy didn't have. So the scope of NumPy was to provide you with numerical interfaces. So quick way to create matrices and vectors. Matplotlib was to plot those matrices, vectors, and related objects. But a bit of scientific computing was still required, like optimization, etc. So that's where SciPy was brought in. Now, these three served as a core for a long time. But then if you see that a lot of analysis is also, so we don't generally tend to see things in terms of just matrices, right? So when we grade our students' exam, do we just look at a matrix? No, right? We look at a spreadsheet where we have students as rows and we have different columns corresponding to assignment 1, assignment 2, quiz 1, quiz 2, and then we have a final total, right? So that's a better model for us to see where these different things are named. You have different names for the columns, you have different names for the rows or different indices for the rows, which you index using the name, right? So imagine if I ask you to update the marks of Tina by 40, right? Put Tina's mark as 40 in the end semester exam. So which of them do you find easier? So spreadsheet of Tina, comma, end sem equal to 40 versus spreadsheet of 34, 46 equal to 40? Probably the former, right? Because you're using the terms, the names which are convenient to you, which represent some value to you. And that's where Pandas came into being. So, Pandas. So now, does anyone know what Pandas stands for? Like Numpy, you said it's numerical Python. Anyone knows what Pandas stands for? Any guesses? So it's not linked to the animal, panda, by the way. And one of the hint is in the name itself, as I'm saying, Pandas and not pandas. So it stands for panel data structures. So you're looking at the panel of data, right? So panel could be a 2-dimensional panel, it could be 3-dimensional panel. So that's where all of this interesting, just a bit of history I wanted to give into you. And in my personal research, I found all of these to be game changers. So the I also used MATLAB for some point of time, but I found Pandas to be particularly a game changer because it just made it easier to do a lot of computation, which Numpy was of course doing. So let's now start with Numpy. Can anyone now tell me why do you think you need Numpy? You have already studied a bit of things, and I know that Udit's session was just before me, I believe. So you have already seen some demos and notebooks already. Can anyone tell us why do you think you need Numpy?
For numerical calculations.
Right, but why is it needed? Like, why didn't regular Python suffice?
To perform with matrices?
For processing arrays and two-dimensional, many-dimensional, multi-dimensional arrays.
But it gives various functions to us to perform.
Yeah, you get various functions, you get some array objects. And in general, Python lists. So list is a structure, container data structure, right? So list can contain anything. So I'm here, but let me start off with here. So this is list of, I believe you should all be able to see my screen now, right? Everyone is able to see the screen, right? Can someone confirm?
Yes.
Let me just increase the font size. So list of something, I can put in some numbers, 12.
Sir, please increase the font size. Some are asking.
Is it better now?
Huh.
I can just.
Yes, sir. Now it's good.
Something.
Now it's visible, sir.
Yeah, I'll just also make it. Okay, so now I've cut away almost all the stuff. So you could create a list like this, right? But internally now the list could have also contained something like this. Like it doesn't make sense to have this heterogeneity for numerical computation. So why not, if you already know that the data is going to be homogeneous, right, of a single data type, why not make use of that? And if you study the Python memory model, you'll see that this is very inefficient. It creates pointers to each of these, which can be discontiguous block, right? So when you create an array in C, you told that you'll get some contiguous blocks, but in Python that doesn't happen. So you always require some good matrix objects and good contiguous memory blocks to store the data so that you can make the computations much more efficient. Because otherwise you have to access the pointer again and you're moving back and forth in memory, which is fairly slow. That's another interesting thing to see. I'll just delete this cell. So let's look at a simple application, right? So I first create a list of 10 to the power 6, going from 0, 1, 2, 3, 4 till 10 to the power 6. And similarly, I'm doing the same thing in a Numpy array, right? So it's a list going from 0 to 10 to the power 6. Now I want to create a list which is a square of each element in this, right? So this list should contain 0, square, 1 square, 2 square, 3 square, 4 square till 10 to the power 6 squared, right? So don't worry if you don't understand this syntax. I'm using something known as a list comprehension in Python. So all this is doing is squaring each element for each element in this array, right? And I'm doing the same thing in NumPy, which is conveniently providing me a function now, numpy.square. Firstly, I've just imported NumPy as NP, np.square of this array. So it will do element-wise squaring, and I'm just using this thing known as a decorator, a magic function in Jupyter Notebook, which can tell us about the amount of time required for running these operations. So I'm running this, and you can see that this operation took about 270 milliseconds. Not that bad, but now contrast this to what the NumPy operation took, 726 microsecond. So orders of magnitude better. And one of the reasons which I just told is that NumPy knows that you have data type, specific homogeneous data type only. NumPy is able to have stored the data in contiguous blocks, and NumPy is using highly efficient code written in C, which is doing this squaring. Whereas now you've written this code in Python, so it's a higher level abstraction, right? So this is showing the power of NumPy on seemingly trivial tasks, which can be very slow otherwise. Any questions till now? Okay. So going from pure Python to NumPy is not very difficult. So let's say this was a list of numbers we had created in Python. So list is indicated by these square brackets. So all of them are just integer numbers. All I need to do is to call this numpy.array function on something which is like a list of numbers, right? So then you'll get numpy.array on array. You'll get, now this is a NumPy array containing of 1, 2, 3, 4, 5 of the data type. So .d type. So .d type is an attribute or a property of this object NumPy array of the class. NP array is the object of the class numpy.array, whose data type is int64. So it's automatically figured out that all the numbers are integers. So I can just store the data as an int64 type. I could have also specified it here while creating d type equal to int32. Right. So now it will, instead of storing it as int64, it will store as int32, and you can see the d type information already here. If I run this, you can see that the d type is int32. I can also keep it to be float32. So floating point definitely requires more memory because now you're storing the precision also. Right. So you would have seen the difference. You're going from 1, 2, 3, 4, 5 to 1.2.3.4.5, which means 1.0 to 2.0, so on and so forth. And now the size is, the d type is also float32. Right. Otherwise, if you just leave it, it will automatically infer what d type to use, which in this case is int64. But what if some of the numbers are numbers you're having? Not all of them are integers. Like in this case, the first number, 1.2, is not an integer. So if you call numpy.array on array, it will create now this array. But if you see, it has upcasted all of these numbers to float. Right. So which is again something common you would have seen in C, C++ like languages also. That you typically upscale or upcast to the highest data type. In this case, it's a float. And if I run this, you'll see that the data type is float64. And I've already shown that you can change the precision. So you can change the precision. In this case, you've set it to float 128. Right? So these are few elementary operations which I'm showing how to create a NumPy array. Any questions till now? Is there any question? Okay. If not, so now it comes to the more interesting things when we are looking at multi-dimensional arrays or matrices. In this case, we'll start with matrices. So what we're now looking at, sorry, is there a question? Right, so let's look at this. So we have this nested list, a list inside a list. So there is one list containing 3 numbers. There is another list containing 3 numbers. So what we have is two lists containing three numbers. Think of them as two rows containing three columns. So thus is actually a representation of a matrix, right? And we can more conveniently just call numpy.array on R, and we'll get this 2 by 3 dimensional matrix if you see. Row 1, row 2, and this is row 1, column 1, row 1, column 2, row 1, column 3. Similarly, row 2, column 1, row 2, column 2, row 2, column 3. Right. So there's another important attribute which you'll reuse again and again. It's the dot shape attribute associated with a numpy.array instance. In this case, np array is the numpy.array instance. Dot shape on this tells you the number of rows, comma the number of columns. So in this case, it's a 2 by 3 list, or sorry, 2 by 3 array. You can also create high dimensional arrays. Of course, the interpretation of them is non-trivial, like 3-dimensional, 4-dimensional, n-dimensional array. So that's what NumPy is also actually. It's an n-dimensional array library. You have similar libraries in C, C++ also. Sometimes you may want to convert the NumPy array back to Python list. Right. So all you need to do is to call this function .toList. Right. So by the way, if some of you are not sure about what to do, so I'm using Jupyter Notebook, but similar things are available in Colab also. So I have this object in np array. I type a dot, I do tab. It shows me all the attributes, all the functions, and all the attributes which are available. Right. So let me do this again. I press a dot, I press tab. So this is just tab completion. Now it's giving me various functions, right? So I'm looking for something which wants to convert it to a list, but I've forgotten, let's say. So I'm looking for something like a list somewhere, right? So I find toList. I also find toString. So perhaps you can, let's see what toString does. Right, toString is deprecated, use 2 bytes instead. Okay, so let's. Okay, for some reason this is stuck. Okay, yeah, this is the byte representation that it has given. Not at all useful to us. Okay, for some reason this is stuck for me. Okay, I think it's back. Right, it got stuck because of the huge overhead it converted into creating a string out of this. So this is a bad idea. We convert this to a list. Oh, I see, because np array, I didn't create a new one, right? So my np array is this one still. So it's 10 to the power 6 numbers. That's why this thing took huge time. Let me rather create this. Right, so now it's a list object. Now to string will also work. Right, so this is just showing the data in some sort of a hex format. You can see this 01, 02, 03, so on and so forth, and then there are some hex 00s. Right, so very useful thing to do. Just press a dot, write a dot, and then do a tab complete. Right, so for instance, let's just look at something else. I don't know. So there's a dot also. So another thing you can do is if you want to read more about a certain function, you've written np array dot. I can just type a question mark after this and press shift enter. So it opens up the documentation. This tells me that it gives you the dot product of two arrays. The good thing about NumPy is that they'll give you good examples also, which you can just copy paste and you can get them to work. But let's not use dot now. But now you know how to use dot. We can also look at .d type. You can again see. We can look at this function called flatten. So what do you think this function will do? Anyone wants to make a guess? on what this function flatten will do?
It changes the dimensions.
It
Single
does what?
dimension. We get one dimension array then.
Right. So flatten out.
Flatten.
You have some high dimensional array. You just flatten it out to a one dimensional array. So you can again read this in this documentation. Return a copy of the array collapsed into one dimension. Right? So let's just see what this returns. Right. So before this, you had something which looked like this: 2 rows, 3 columns, total 6 numbers. So the total number of numbers will obviously remain the same. But now you have 1, 2, 3, 4, 5, 6. Right. So it's flattened along this dimension. First it goes here and then it goes into the row. You could have also done, so from the documentation I'm reading, that you can also give a different order. So if I give order equal to F, so C and F stand for C, C stands for, C++ ordering, and F stands for Fortran ordering. So I could have also done this, and now you'll see something else. So you see 1, 4, 2, 5, 3, 6. That's how it's flattened out. So these are all useful operations if you want to do something. But anyway, leave it here. This was to list. Any questions till now? Okay. There are quite a few helper objects in Numpy to create some specific type of arrays. So one is an array of zeros. It's called np, so you can invoke that by np.zeros and then you pass in the shape. So np.zeros of 10 will create an array of zeros, right? So there are various ways in which you can use these arrays. For example, you pre-initialize some table and then you can keep on filling the entries here. This is usually very efficient. So numpy array is equal to np.zeros of 10 and the d type is float 64. You can similarly create an array of size 3, 4. So the important thing to note here is that you have to give now this, if the shape is more than one element, so you can't give, so if you give 10, 10, you won't get a 10, 10 matrix, you'll get an error because it cannot interpret 10 as a data type. What is required is whenever you go more than one dimension, you need to give it like this. Now it's a matrix of size 10, 10. But if it's only one dimension, you can just pass it as an integer. If it's only one dimension, can you also do this? Let's try out. I don't recall. Yes, this can work. This also works. But if I do 10, 1, now I'll get something else. Can someone tell me the difference between this and this?
It's transpose.
No. I mean, it is transpose, but there is something else also. So NumPy has this special array. Now this is 10, or just 10. It's a 1D array. If you see only one square bracket. As soon as you give 2, now this is the 2D array. So this means 10 rows of one column each. So you have 10 rows, row 1, row 2, row 3, row 5, row 6, so on and so forth, row 10. Each of them have one column each. If you instead had 10, 2, so 10 rows of 2 columns each, but all of them are entries zeros, right? Any questions in this? So this is one thing which a lot of people make mistakes in, specifically the 1D array. So it's a little confusing. I generally recommend to just keep it as a matrix. So just do 10, 1. Until unless you're very sure that you're dealing with. So basically, this is a vector and this is a matrix. The numbers, the total number of numbers is the same. It's just that you think of it as a matrix or a vector. That's something useful you want to remember. You can also quickly verify the data type. It's float 64 by default for numpy.zeros. You can similarly create an array of or matrix of size 3, 4, but this time instead of zeros, I'm using this ones. So you don't have all the numbers, but you have zeros and ones. So np.ones of 3, 4. So 3 rows, 4 columns. D type equal to int32, so that you have integer data type and not the floating data type. Another interesting thing you could do is to, if you want to do some constant into this, it's a 7 into ones. So all the numbers will now be 7 into ones. Right. Any questions till now? Or anything you want me to demonstrate, that also we can ask. I'm not necessarily in the flow, but if you have questions otherwise about any specific functionality of Numpy, I would like that because that would be more useful to you. But otherwise, I have already this prepared notebook and I can keep going in that direction. Okay. So numpy.arange. Arange is another interesting function. So you want to get a range of numbers. You give a start, you give a step, and you give a stop. So this is equivalent to how you would write a for loop in C++. For I equal to 2, I less than 20, I equal to I plus 3. This is what you're effectively getting. But you just get it in a single line of code. So 2 to 20 in steps of 3. Right. Another useful function is Linspace. So it linearly spaces out and creates an array. So I want to start at 3, stop at 2, and linearly space out 5 numbers, right? So 2, 2.25, 2.5, 2.753. So these are 5 numbers linearly spaced out in a gap of 3 minus 2 divided by num minus 4. So that's the gap that we'll be using. And you get this array. So these are very useful things to create. So for instance, let me, although we are not doing matplotlib here, but I'll show you why I use the linspace method. So you don't need to worry about the matplotlib syntax. np.linspace 0, 1, and 101 numbers. Y equal to np.sin x. So you can't see much in this space. Right? So can you see now the sine wave being produced? I have done is that I go from 0 to 6.28. I've created these 101 linearly spaced or evenly spaced out points. I can also show them to you, I think. Right? So you see all of these points. These are the 101 points. Right? So these are the 101 points linearly spaced out between 0 and 1. So on the x-axis, these are the 101 points, and corresponding to them, you have the y points. Right? So you can also see x. So it's linearly spaced out points between 0 and 2 pi. And y is the sign of each of these values. So np.sin x will do sin 0, will create a list of equal length as x, numpy array of equal length as x, and do a sign of each of them. So the first element is sin 0, the other is second is sin of 0.06, so on and so forth, and last is sin of 2 pi, which is again 0. So this is where the linspace is particularly useful. I find it particularly useful. Any questions till now or in this? So because this plotting just makes the whole thing very interesting. This is the kind of things you'll very often do in machine learning. I typically generate my own data many times when I'm teaching machine learning or when I'm learning some new algorithms. For example, if you do some linear regression or something, I would typically do something like this and add some noise to it and just learn the machine learning model. So for instance, I may, if I want to show you how a linear model works, I may do something like this. So X I have created. And y I would say is, let's say, 4 into x plus 5 plus some noise. So I'm adding some random noise. And its size is just x dot size. That's the number of elements you have. Let's first just plot it. I don't need to see x. I don't need a marker now. Right, so I can, instead of this, make a scatter plot. So you have these 100 odd points. Right, so you have these 100 odd points. So you're trying to learn some linear relationship between y and x. This is a ground truth linear relationship, which I already know, 4 into x plus 5. Plus I've added some random noise. So all you now need to do is to, let's say you're using sklearn dot linear model import linear regression LR equal to linear regression LR dot fit. I'll be using something called x dot reshape minus 1 comma 1 and y. So this is needed because scikit-learn wants matrices. So it wants samples comma features, whereas x is currently just a vector of shape number of samples, right? So x dot reshape minus 1 comma 1. This is basically saying that I'm reshaping it to have one column and arbitrarily number of rows, which you can automatically determine. So minus 1 means you can automatically determine LR dot fit and LR dot QF, comma LR dot intercept. Right. So this is now telling us that we have learned this model, this linear model with a coefficient of x to be 3.98 and the intercept to be 4.98, so which is fairly good. Now I can also make use of these and draw another line. So I can again make use of Linspace, which I've already done. So I can create another array, pred array. I'm trying to now predict for all the points between 0 and 2 pi with a space which was as given as this. So 101 points between 0 and 2 pi. So pred array equal to LR dot coefficient, the first element of this, into x. So basically I'm creating something like this, plus LR dot intercept and PLT dot plot. I can plot x versus y again, pred array, and I can just make this in black color. So this is the line I've learned. So this is basic machine learning for you using sklearn, but this was showing that how Numpy, how the entire thing, how each of these modules are related. You use Numpy to create randomly or evenly spaced out data. You create some random data. For the purposes of illustration, you can do a scatter plot in matplotlib to make all these dots. You're using sklearn to create a model, and then once you've learned the model, you're showing how the fit looks like. So, any questions till now? Okay. If there are, so if all of this is boring, you can tell me. I can move quicker, or I can move to more advanced topics. Or if you already know all of these things. Okay, perhaps a no means I should continue with the notebook. So another very useful thing, which you would have already seen I've done here, is random. So I've added some random noise here, right? So I can do the same. I can create a numpy.array. So numpy array containing uniformly random samples between 0 and 1, right? So this is of size 2, 3. So 2 rows, 3 columns, and it is going to generate these. So the interesting thing is, if I keep repeating this, I'll keep getting different numbers. So this is because the random seed changes. So can anyone tell me if these algorithms that we're using in numerical computation, are these truly random algorithms, or are they pseudo-random algorithms? Yes, anyone? So these algorithms are known as PRNGs, pseudo-random number generators. So the algorithms which are used to generate these random numbers, these are pseudo-random number generators. They're not pure random number generators. For getting pure random number generator, you need some actual sources of noise, like let's say something in the physical world, right? So those are not using computer models. So these are some deterministic algorithms which almost seem like random, but they're not actually truly random. That was just an aside. So what is happening is that the random seed, so these algorithms depend on some arguments, which is known as a seed. So seeding number for generating the random numbers, right? So each time I run, the seed will change, and thus I keep getting different answers, differently generated numbers. Sometimes you want a same generated random number because you're doing some experiments. You want the results to be reproducible. So you can then set some random seed, np.random.seed to be any number you want. And then if you see, if I keep on repeating this, executing this cell again and again, I'll get the same number, right? So there are various other important functions you can again see with random. So again, I'll suggest do np.random. So again, if you see, I just do .r and I did a tab. So I press tab here. It shows me all the possible options. I do random .tab. It shows me all the possible things I have. So I have exponential, gamma, geometric, Laplace, logistic, multinomial, negative, normal. Let's say, what does normal do? I want to know. Put a question mark, run. So it draws random samples from a normal distribution, right? So location means the mean and scale means the variance. So this is also interesting. We can verify, are we actually getting samples from this or not? So let's say I want to verify this. I get location equal to 0, I give the scale equal to 1, and the size is some 10,000 numbers I generate, right? So I'll just call it NO, right? So I have these numbers. I have these 10,000 numbers supposedly coming from a normal distribution between 0 and 1, but I can verify this. I can do a matplotlib, I can do a histogram on this. So does this look like a normal distribution to you? Yes, anyone? Anyone has thoughts on this? Or is everyone very tired already? So does this distribution look like a normal distribution?
Yes, sir.
Right?
It's normal
So this is again something you can very quickly verify. That's how I also suggest how to run these notebooks. So let's not just run code. Try and visualize things, try and understand things better. Why does this make sense? Why does this not make sense? Any questions till now?
Sir, some question is in the chat box. Please go through the chat box.
Okay. Clear these. Numpy relationship is used for plotting in various data range or for some specific purpose. Can you clarify questions, please, Dr. Sriram? Dr. Sriram, are you there? Can you clarify your question? So I didn't fully understand the question. So there's another question, Matplotlib and Seaborn, which is better to learn for chart and graph. Start with Matplotlib, then learn Seaborn. Seaborn is for more advanced graphics, but Matplotlib is what you should start with. So I'm not fully sure what Dr. Sriram is asking, but I can just attempt based on what he's asking, my understanding. Numpy relationship is used for plotting in various data range or for some specific purpose. No, I'm still not able to understand. Dr. Sriram, if you can clarify your question, please.
Sir, actually, he wants to tell something, but his voice is not coming.
Oh, okay. Okay. That's fine. Whenever you're able to ask, or if you can just clarify this in the writing, that what is the question that you're trying to understand. So relationship between Matplotlib and Numpy is that Matplotlib can plot Numpy arrays. So Matplotlib is generally expecting X versus Y arrays. So you're plotting X versus FX plots. That's what it is. But it need not be a Numpy array. It can also be a Python list. But I generally recommend to stick to Numpy arrays also only. So the general syntax is right. So the general syntax is plt.plot. If you see, it's plot y versus x as lines of marks. So let's say my x is 1, 2, 3, 4. So I'm just illustrating that Numpy list will, Python list will also work. I'm plotting y equal to fx equal to x square. Right, so you see that you've been able to plot this. You can also, there are a lot of options. You shouldn't expect them to learn in this, all of them in this short duration of 1.5 hours. But this is just to motivate the kind of things you can do. So that's my main takeaway. Don't worry if you forget the syntax. Don't worry if you understand specific parts of it. But keep asking questions so that we can tailor the discussion in that direction. And these notebooks will anyway be with you. So some of these things which I'm saying I've been doing for the past 9 years. So that's why I can say some of these things. But don't expect to learn them immediately in 1 hour. And I think that's also one of the purposes of this FDPs, these faculty development programs, is to ensure that you go back motivated so that you can learn more things. So in this shortest period, we can't teach you everything which you will retain. So you'll forget those things, right? So I'd suggest that keep that motivation. Don't worry about trying to just muster everything and remember everything, but just become motivated to do these things. Other questions? Anything cool you want me to show? Or any doubt you had thus far in machine learning? Okay. So indexing, slicing NumPy arrays is very, very important. So you have this NumPy array, right? Now, again, as I mentioned, A range. A range is giving you numbers from start to end, -1 in steps of 1. That's the default step. So you get a range of 5 to 14, 5, 6, 7. Now this is a vector of size 1, right? I mean matrix of 1 column, or this is the vector. So let's keep it as a vector. Now I want to access, you would have seen that Python, C, similar languages is 0 indexing based, right? So this is the 0th element, this is the first element, this is the last element, right? So if I want to access this element, I can write AR, which is the name of the object, of 0. So this is the 0th element, ARR of 1 is 6, ARR of 2 is 7, so on and so forth. right? Now, what is interesting about NumPy and Python and some of these syntaxes, it also gives the negative indexing. So if I want to get the last element, one way is to give array of length, array of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I can find out that the last element is the 9th element, and I can give ARR of 9. The easy way is that you start negative indexing. ARR of minus and 1. So it means start from the behind and give me the first element. Start from behind and give me the third element. So give me the third element would be 14, 13, 12. And that's what you get as the answer. Right? Any questions on indexing? Okay. So we can also now do multi-dimensional indexing, which becomes much more useful and much more interesting. So now you have a NumPy array of size 2 rows, 3 columns, and it's randomly generated using uniform sampling. So you get this 2 cross 3, so 2 rows and 3 columns. Now, if you want to access the first row and the second column, so this is the entire thing is the first row. First row, second column. So first row gets you the first index is 0, and the second columns, the index is 1. So thus, if you do array of 0, you get this, and amongst this, if you do 1, you get this. So thus, if you're trying to access the first row and second column, you do ARR of 0, 1. So if you get this, if you understand this indexing, you've probably understood the most important thing in NumPy arrays, according to me. Any questions in this?
No, sir.
Okay, good. So I'll probably jump directly to some maths. There are a bunch of other things. They are already in this notebook, which will be shared. I'll share with the corresponding link for the FDP, and they can then share it with you. So doing math on arrays is very interesting. So I had this error, numpy.arange 4. So it gives me number from 0, 1, 2, 3. 4 numbers I get. Now, this is my array. If I do array plus 5, so if you just write array plus 5, what it is effectively doing is that it is broadcasting this 5 to the same shape as this. So it also makes 5 as a one-dimensional vector of length 4, and then it elements wise adds 5. So 0 plus 5 is 5, 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, right? So doing this is basically equivalent to R plus NP plus 5 into create a. So both of these are equivalent. R plus 5 or array plus 5 into np.1s of 4. So this creates a vector of all values 1 of size 4, and you multiply each of them with 5. So your vector becomes 5, 5, 5, 5, and you're adding it to this array, which is 0, 1, 2, 3. You do element wise addition, and you'll see that both of them are the same. So the only difference being d type equal to int. Now you see that both of these are the same, right? So this thing is known as broadcasting, very useful thing in NumPy arrays. Similarly, you can do other operations also. So this is now array 1, this is array 2. You can add these arrays. So 3 plus 5, 8. So all I need to do is to write array 1 plus array 2. 3 plus 5, 8, 4 plus 6, 10, 5 plus 7, 12, 6 plus 8, 14. And I can also do element-wise multiplication since both of them are arrays. So 3 into 5, 15, 4 into 6, 24, 5 into 7, 35, and 6 into 8, 48. And this is what you get. Questions on this?
Yes, sir. Continue.
There are other functions which I already showed, like I showed this sign function, right? So it applies the sign function element-wise on each element in the array. Similarly, you can do a log function. Similarly, you can do an exponentiation function. The best way I generally suggest to learn these things is to, again, do x equal to np.linspace between 0.1 100, and let's say you have 1000 points. Y equal to np.log of x, and how do I give the base? Is there a way to give the base? Anyway, let's just run this. So it's plotting x versus log x. I can also just give log x. So this way you can also quickly verify what the different functions you're doing. So you can also create multiple such functions. I can do y2 equal to, that's a sine of x. Right, so you see now you have two different functions being plotted, different color with the legend. And if I do, interestingly, exponentiation, this will clearly go, so this is e to the power x basically now. And this will make the others look very small, of course. Right, because exponential is way quicker growth. Right, so again, this is how you can use different trigonometry logarithmic functions.
Sir, what is the use of this legend function?
So legend is now showing you, if you make a plot, that which color corresponds to which line. So let me remove this to first make it clear. So see, blue color is showing the log. So legend is basically, it takes the labels corresponding to different lines and it plots them. So if I don't put legend, you'll not see those legend. Right? Does it become clear?
Okay, sir. Yes, clear.
Okay, other questions?
No, sir.
So there are some very useful functions in Numpy arrays, such as sum, mean, minimum. So if this is the array, I can call array1.sum. This will give me the sum of all the elements. I can do .mean, .minimum, .argmin. Argmin tells me where is the minimum occurring. Right, so the minimum occurs at index position 4. So sometimes this is very useful. Right, so the minimum is 0.35, but where is the minimum occurring? So that is by argument, which minimizes a particular function. And right, so with this I'll stop with Numpy. Again, I'll share this with you, so you have a bunch of things to do. I'll move on to Pandas. Any questions till now?
Sir, please go through the chat box because one question is there.
I want to ask whether you discussed about removing the noise from the graph to get good plotting or something else. So what do you mean by noise from the graph? And which graph are you talking about? I'm not sure now. Dr. Sriram? So if you're talking about this graph where I was, perhaps you're talking about this graph. So I have not removed the noise. I am just learning a linear regression on top of it, which is a best estimate, right? It will try to learn a best estimate of relationship between y and x. Look at the errors for each of these points corresponding to different lines, and it will see which line is the best, which minimizes the sum of squares of these errors. And this turns out to be the good one. But of course, if the noise was higher, right, so if the noise was much higher, you'll see that now it seems that this is still the best line, but it's not seeming that well. The trend is not seeming that well. But if the noise was even higher, now it's almost random, right? The trend is almost equivalent to the noise. If you go even higher, now it's almost random, right? So you have y equal to 0 as the best prediction, and it's just random noise above it. Does that answer your question? Okay, good. So we can now move on to Pandas. Are there other questions, please? Okay.
No, sir.
So we'll now move on to Pandas. As I mentioned, it's panel data structures. And as I mentioned, whenever we're talking about Pandas, think of a spreadsheet, right? Think of rows, columns, indices, and column headers, right? So Pandas mainly provides two kinds of objects. So like in Numpy, you had numpy.array. That was the main kind of object. In Pandas, you have two kinds of objects, series and a data frame. Series is like a 1D array, right? So if I run this, you've just created some array, random number of 5s. You create a pd.series. Pd.series is a series of numbers, right? So if you run series, you see this. Now, it's also important to see the difference between. So can you tell me what is the difference between series, because this is the output of series, and ARR, array? So how does this look different to you compared to this?
The series is a two-dimensional.
So series is actually one dimension, but this is the index of it. So the index is 0, 1, 2, 3, 4, but you're heading rightly. But the index is now a range index. It's a range of numbers going from 0 to 4. But what will become interesting is that at this point, so I set the index manually, and now this is telling me something useful, right? So now this is telling me that A corresponds to 0.32. So I can give a non-numerical index also. So think of this as some index, and these are the values, right? So A corresponds to 0.32, B corresponds to 0.35, C corresponds to 0.27, D to this, and E to this. Now, this is where it becomes very interesting. Now, I want to find out the marks which B got. So I can directly write series of B, and which tells me it's 0.352, something, right? So another reason why this becomes very interesting is that, by the way, Pandas has its own set of plotting also, which is very convenient. So I'll make a bar plot. See, A, B, C, D. So I very often use Pandas series, specifically when we have some labels associated with these things, right? So think about if you're doing some machine learning approach, right? So this could be decision tree. This could be SVM, and these numbers are the accuracies. This could be Gaussian processes. This could be neural network, and this could be random forest. So now it doesn't have a B, obviously, as a random forest. So now you can very directly get this plot, right? You're comparing the different approaches. Of course, you don't want these labels to be rotated, so I think, right? And if you want, you can also interface mat.lib with it. So I want to just give X label is my approaches, Y label is my, let's say, F1 score, which is one metric used in machine learning. Right. So this is now a plot ready for you to submit in your report, in your publication. Right. So if you see, Pandas is so very convenient for these things, for quickly putting data in a Pandas series, and you can very quickly make bar plot or other kinds of plots. Any questions or anything you want me to particularly show? Otherwise, I can keep going in this flow. Again, as I mentioned, if you ask questions, I can cater to those specific, and that would be very useful for you.
No questions, sir.
Okay. But this is something I definitely want you to take away, these kinds of interesting plots. I can also do, so now I have these series objects. I want to, let's say, see the numbers for series between SVM and neural network. I don't want to look at decision tree to RF. So I can do this kind of indexing also. So SVM, starting from SVM, going to neural network. So these are the three numbers I care about. Now, there are various ways in which you can create Pandas series. By the way, if some of you are feeling I'm going too quick, because you need to realize that because it's only 1.5 hours. Like I can cover the same material which we're covering in 1.5 hours in, let's say, 40 hours also. But given the limitations of time, I'm going much quicker. Again, as I mentioned, the aim is to motivate you to go back and see what are the possibilities rather than to teach you each and everything, which you can figure out on your own. The documentation online is fairly good. So there are various ways of creating Pandas series. One is from Python less, which we've already seen. So what you can also do is to give an index here itself. So index is also list A, B, C, D, and E. So now if you see, you have the index also, A, B, C, D, E. A corresponds to 1. So this is much more convenient rather than NumPy array. But this is also, just remember correctly, remember it's still a one-dimensional array only. So think of it as, just 1 second. Right, so this is, think of it as I'm dealing with a spreadsheet. So what this series is corresponding to is index and values A, B, C, D, E, and then I have these values 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this is a Pandas series. This thing is a Pandas series. You have an index, you have values. It is equivalent to a spreadsheet, but with a single column, right? But if you have to look at data frame, so the only difference is that instead of this values, which is a single header now, which is single header, you can have age, marks. So now these things also have names. Previously, that was only values. So in a Pandas series, you have just values, right? But now if you have a data frame, you can arbitrarily name these columns. Could be age, marks, height, right? But the index remains the same. So index would correspond to, let's say, Ram, Sita, Jesus, Muhammad, anything, right? So that's one way to think about the difference between series and data frames, and how are they linked to NumPy. So the relationship between NumPy and this is a NumPy array. This is a NumPy array. This is a NumPy array, right? So now you have better data structure, which consists of NumPy arrays in between. Any questions? Okay. So another very interesting way to create a Pandas series is by using something known as a dictionary in Python. So dictionary is again a key value pair. You have a key, corresponding to that there's a value 30, key professors value 5, key deans value 2, key interns value 6. If you do a pd.series on this dictionary, you get a series like this, which is again index value, index value, index value, index value, or key value, key value, key value. Right? Now we come on to data frames. This is where a lot of power comes in. I have already shown you what a data frame is. So let's say that these are the different people. I want them to be an index in my data frame, right? So these are the weights, these are their heights. I've already shown that these are weights and heights. So let me first create an empty data frame with just the index. So df equal to p.data frame index equal to people. So now it just creates an empty data frame with just the index. There is no values. So this is corresponding to just saying that we have Alex, Bob, Cooper, David, and Alan. So this is all I have as of yet, right? So this is what I've created. This is my empty data frame till now. I can create this df of weight equal to weight. So if I do this, it will now create a column weight and put the corresponding numbers. These numbers are now a list of numbers or a numpy array. 50, 55, 45, 65, 60. So 50, 55, 45, 65, and 60. Now, if you see, this is the spreadsheet that you're seeing, and this is what you're seeing in Python output. So both of them are exactly the same. And you can similarly add the height also. df of height equal to height, and after that it will become something like this. .5 and 1.3. So I usually prefer having this analogy of the spreadsheet open because that helps you to understand that what exactly is going on, right? So this is now exact same thing that you're seeing here. You can now use this method df.columns to tell me all the columns that I have. So it's weight and height. df.columns para gives me that. Right, so it shows me that I have weight and height as the columns. I can do df.index. That will tell me that these are the index values. I can also do df.values. So if I did do it df.values, it will give me all of the values, whatever number of rows, whatever number of columns I have as a numpy array. So if I do df.values, I'll get 50, 1.2, 55, 1.4, 45, 1.0, 65, 1.5, 60, 1.3. So I'll have 5 rows and 2 columns. So you can see df.values is 5 rows and 2 columns. You can also confirm this, right? So 5 rows and 2 columns. Okay. Any questions? Questions would be good. Otherwise it will just get monotonous. I'll feel that I'm just speaking out to no one.
Hello.
Yes.
Sir, how to find a particular weight value using index?
Okay, so let's go to the spreadsheet. Okay, what do you want me to find? So what is the query?
Sir, yes, sir. Weight of Bob.
Weight of Bob, right?
Yes, sir.
So good. So you have this df. Your df looks like this, right? So let me just go up. So df of Bob, it gives me now the entire record. Just 1 second. Right? So it gives me the entire record. Weight is 55, height is 1.4. I can then just specifically figure out the weight. Right? So .lock, it says that let me find that location corresponding to a particular index value. That is Bob. But corresponding to Bob, I'll get both the weight and height. If I want only the weight, I put this weight also as a selector. Right?
Okay, sir.
So let me ask you questions and let's see. So, okay. So can we find out the maximum weight in this table? So the value should be 65, but how do I find that? Can someone tell me what should I write?
df.max something.
df dot?
df location weight dot max.
Right. So df, if you do df.max, it will tell you that it will then call the maximum operation on a column-wise basis. So for weight, it is 65. For height, it is 1.5. So you could also do this way. You've now figured out. So by the way, this is a series now. Index value, index value. So df.max of weight is 65. You could have also done df of weight. Now this gives you a series. Alan is 50, Bob is 55, and you can do max also. Right? Does everyone follow? Any questions in this? Okay, so let me ask you a more tricky question. Can you tell me the height of the person who has the lowest weight?
Min. DF dot min.
So df, sorry, what did you say?
Min.
So df.min will tell you, no, I want you to find out the height of the person who has the minimum weight. So I don't want you to tell the minimum weight. I want you to find out the height of the person. So the minimum weight is 45, belonging to Cooper, whose height is 1.0. So I want you to the output to be 1.0.
So df height, df weight dot df height dot min.
Okay, let's go a little slow. So df of
DF of DF.
df of df. Okay, so you already
df
know.
height, df weight,
So df of weight
weight
dot.
dot df.
So you don't do a df.df, but let's see.
Okay.
So df.weight.
Sir, we have to know nesting.
Right. So you have to do nesting, but I'm just trying to walk you through this step. So df of weight dot min. It gives you the minimum weight, 45.
Yeah.
But I want actually the index corresponding to that. So that is 2, right? So index number 0, 1, 2, right? So I could now find out the second element is belonging to the minimum weight. I can now do, so let me assign this some temp variable, temp equal to 2. I can now do df of height and dot 2 will not work, so I'll actually do ilog.
Yeah.
Right? So these are some other advanced things, but it's showing that I could have got this. I could have also just combined this in one step. And so some of this would look a little magical to you, but again, if you practice it enough, this will seem like natural. Right? Okay, so I want you to now tell me the name of the person whose height by weight ratio is the maximum.
Sir, instead of height, we have to write. Okay, there is no name.
So height by weight ratio, or sorry, weight by height ratio, whatever. So first, let's see. So this is a DF, right? So let's try and add another column. So I'll just call this W by H, weight by height. So this is another convenient thing. So I have df.weight. This gives me a sequence of numbers. I can just use a divide. Height. Right. And if I now view df, so it gives me these numbers now. Weight by height is 41.6, 39, 45, 43, 46. Now I want you to find out the person whose W by H is the minimum, right? That's it. So W by H dot argmin and df dot index. So this tells me it's for Bob. So we can also rather go here and just look at DF. So indeed, it's for Bob only that the index is the minimum, right? The for Bob, the weight by height is the minimum, right? So df.index is telling me that, you see, it's giving me a sequence of or a list or a numpy array of these index or these names. And this so argmin will tell me where this is minimum. So you have 0, 1, 2, 3, 4. Corresponding to 1, you have the minimum. So argmin just gives me 1. So then I have to look for 1 in this index. So 1 in Alan, Bob, Cooper, David, Edwin. I look for 1 and that turns out to be Bob. So 1 in this. 0, 1, 2, 3, 4 and 1 is corresponding to Bob. So that's how we can find out. Right. So this was also showing you how to create another new column. So there are practically millions of things you can do this way in Pandas. Okay, so why don't you throw some question related to this, similar to this, anything else you want me to ask or to show? So since you're not asking questions, let me show you something. So df2. So this is now, it can create various different output formats, which is very interesting. I can create an HTML table out of this, right? So this doesn't look like an HTML table to you, like it's non-trivial to parse, but let me, in fact, I can just copy paste this and show you. I will create a new something in Visual Studio Code, let's say. And put it in my desktop. Right, so I created something. I think, let me try and open this. I've not added the HTML tags, etc. So let's see if it works or not. See, if you see, now I can see this table. Of course, there are some new lines, something else which has also come up, which should not have come up, but you've been able to create this table quite easily. In HTML also, you've been able to export from a data frame. You can also export it to CSV, comma separated values. And I can give the path also. So I can give hello.csv and sorry, was there a question? So I can open this. I can open this hello.csv also. I think it went in downloads. Right. So now if you see, I've been able to create this. I've been able to open the CSV file in Excel or similar things also. You can do that. So that's another very useful thing. So for those of you who write code in LaTeX or who, write papers in LaTeX. So I very often do that. I can do to LaTeX and it will give me this beautifully generated already this table in LaTeX, which I can directly copy paste into my paper and I'll get this rendered. So quite a few things which these output formats can do. So otherwise also again, you can do dot and you can look at all the interesting things. So you have correlation. So let's see this. So this now looks at all the columns and generates this correlation matrix. So this is telling me the weight and weight is correlated by 1, expected, height and height is 1, weight by height and weight by height, weight by height and 1. Weight is very positively correlated with height. Of course, this is a positive semi-definite matrix. So these entries would be the same. This would be the same and this would be the same. So this is probably suggesting that weight by height and height are not so closely related as the other things. I mean, this was just some arbitrary data, but this is again something very useful to create these kinds of correlation matrices. You can use these in machine learning. How are the different features related? Right? If you do some standard data sets, you can do that to do this. You can also export this in terms of matplotlib figure or Seaborn. So since someone was asking about Seaborn, I can create a quickly heat map out of this. Right. So this is again very useful to put in your papers. Quite a bunch of other things you can again do if you just keep on playing with df dot. So dot apps, it will create an absolute value for each of the values you have in the data frame. You can do, so dot describe is very useful. It just gives you a summary. It gives me that there are 5 values in weight, height, and weight by height. The mean weight is 55, the mean height is 1.28, the mean weight by height is 43. The standard deviation are these. The minimum 35th percentile, 50th percentile, 75th percentile, and the max is this. So in quick summary, you can get to know what the data frame is. You can also do df.boxplot. So it tells you, showing you the box plot for the weight, height, and weight by height. So it shows you the median, 25th percentile, 75th percentile, and the interquartile range. So again, a fairly useful way to plot. You can also do dot plot kind equal to bar. So if you want to just do a bar plot of this data frame also, so you can see that you'll have weight, height, and weight by height for all of these 5 people. You can again just do rho equal to 0 to ensure that there is no rotation. Another interesting thing you can do is to, so what is that called? Let's see, find subplots. So now instead of having them on single plot, you've created some subplots. So quite a bunch of things you can do if you just play around with Pandas. You do a dot complete, you look at the various methods, you see what are the options. So I'll stop at this point. I'll take any final questions before finishing the session.
Sir, I have a question in correlation part.
Yes.
Once I did the correlation, and then if I wanted to print or wanted to get the, like, how much, which feature or which feature is actually highly related with weight,
Right.
and how much. So, I mean, I just want to know the syntax.
Right. So this is your df.core. Right. So if you want to look at how different features are related with weight, so you can then firstly just visualize this. But if you don't want to visualize this also, you can just look at if you just do this weight, so this will give you this column, right? And in this also, you just want 1 onwards, right? Because you don't want the correlation with weight itself. That doesn't make sense. And you can also, interestingly, you can just sort these out and then you can plot. So you can do dot sort, although they're already sorted. So dot sorted, is that the method? So values sort. So there is something for sorting Pandas series. Sort values, not values sort. So this kind of figure is very common, and then you do a plot, and you do a kind equal to bar. So this is typically what you do. This is the entire pipeline. You look at the input data frame, which has different features. You find the correlation matrix. You look at the output predicted variable, which is weight. You discard its correlation with itself because that's not required. You sort the values, then you plot a bar plot, and this will be in increasing order of telling you which of the features are more important. So you could have also done ascending equal to false. Right, so now you get in the descending order.
Thanks.
Yes, other questions? Yes, any other final question? Okay, then thank you. Thank you everyone for listening and for asking questions. I'd request if the organizers can also share the feedback with me, that would be useful. And I'll anyway share these 2 notebooks right away with the organizers so that they can share them with you.
Okay, sir. Thank you so much.
Thank you.
Sir,
Thank you, sir. Thank you very much. You gave a very wonderful lecture. It will be
Thank
very
you.
useful for us.
Thank you. Thank you, everyone. Okay, so I'll take leave. I'll request the organizers they can share the feedback, and I'll share the notebooks anyway with them. Thank you.
yes, sir. Definitely, sir. We'll share. Thank you. Thank you, Dr. Nipun Batra, sir, for sharing your knowledge with us. We have definitely gained from the practical sessions that you have conducted, along with the explanations that you have done related to Pandas and Numpy. Hopefully, all the participants must have gained an insight on using Pandas and Numpy, and they can use them very extensively in their research. Thank you, sir, for sharing the knowledge. I request all the participants to fill the feedback form for this session, and we will meet at 3 p.m. in session 9. The topic will be training and testing data visualization using Matplotlib by Dr. V. Rao Kagita. Dr. Kagita has already taken session 6 yesterday. He's from NIT Warangal. So hopefully all of us, all the participants would gain a lot from him also. So please fill the feedback form, and we will gather together at 3 p.m. So I will request all the participants to be there before 3 p.m. Around 5 to 10 minutes before 3 p.m. Around 2:50 p.m. Thank you very much.